Here we have an example of an apparatus we can use to measure the force that our actuator can apply. Here's the motor, the flexible coupling, the screw actuator, the screw here attached to this piece of foam, and attached to our piece of foam I have a wire with washers. The motor is attached in this case to 5 D cells, which gives us 7.5 volts. If I apply the power, indeed our actuator can pull up this number of washers. So if we reverse the circuit, bring our actuator back down, reverse the circuit again, we can continue to test to determine how many washers our circuit can lift. And we can stop at that point because we can tell that our motor is laboring, and this would be the maximum force that the actuator could pull with 5 D cells or 7.5 volts. Here's an apparatus we might use to explore the force required to move an arm if it had a standard weight at the end of the radius and ulna. So what we have here is our foam apparatus with a series of holes punched where the insertion of the muscle or the lever would be attached. And I have a Newton scale, and if we start at this last opening, we can pull up our Newton scale and we read about 0.7 newtons at the furthest end. If we go closer to the fulcrum, and again look at the force required, now the force is 0.9 newtons in order to pull up the same amount of weight. Move it up a couple of notches, getting closer to the fulcrum, 1.2 newtons. And at our closest point, 1.7 or 8 newtons. It's taking a lot more force in order to pull up our mass. In our applied example, here we have our actuator attached to the humerus, and we have these brads in here that allow us to adjust the angle. And then over here is the pivot, or the straw, which is the actuator arm, attaches to the radius ulna. And if we activate it, you can see that it'll pull up the arm with no masses attached. So what we can do is we can attach our masses. Start very small with one large washer and see if it can do it. And we're about at the limit. So again, we can apply what we know about the actuator's ability to apply force, what angle and where the insertion should be, and then what we could predict as far as the applied force at the end of the arm.